Okay, in the previous video leading up to the intermediate value theorem, we focused on output values. We wanted to see if the output value k was between the two output values f of a and f of b. In this video, we are going to focus on input values, okay? So the input values, what we were plugging into the function f of x, were a and b. That's how we got f of a and f of b, the output values. We had to plug in a and b, the input values. Now the output value k was the result of the input value c. It was some mysterious number that we didn't really identify, right? We were just given the output value, and so we didn't have to figure out anything about the input value c. In this one, now we want to focus on the input value c. So let's say that we have some function f of x, and let's just make it something simple, x plus 5, okay? On the interval from a to b, okay? And now down here you can see that the interval from a to b is -3 and 4. So a is -3 and b is 4, okay? And what we're going to say now is if f of c is equal to k, meaning if you were to plug c into this function and get the output value k, then is the value c, is that a value that's on the interval from a to b? To be on a closed interval means to be in between two numbers. Now, you're going to hate me for this, but being in between two numbers on a closed interval means that it could be a or b. It could be equal to a or equal to b because it's on the interval and it's closed. It's got the brackets, so that's including a and b. So really what we're trying to figure out is c a number that's between a and b? Now, since now we're given this information down here, we're told that k is equal to 6, and we're told that a is -3 and b is 4. So this interval from -3 to 4, okay? Let's draw a number line here, okay? So we got okay, so let's say we got here like -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, and 8, right? A is -3, right? That's right here. Boom, -3. B is 4. Boom, that's right here. And what we're trying to figure out is the value of C somewhere in here, okay? Is C in between -3 and 4? Now you may say, well, isn't C 6? So it's not. No, K is 6. That's the output value. See, look. C is the input into f of x, and that generates an output value equal to whatever k is. So k is an output value. So we want to know is, does the value of C produce an output value of 6? Well, this says that it does. It says if C plugged into f of x produces an output value of k, well, then, if that's true, then is C a value between -3 and 4? That's all we're trying to answer here. And I'm making it sound a lot more complicated than it really is. All you have to do to answer this question is plug C, or excuse me, not plug C, sorry. Take your function, your f of x, okay? Replace the x with the letter C, and then set it equal to your output value here, which is 6. So here's what we're going to do to solve this, is we're going to take x plus 5 and we're going to make it c plus 5. We're plugging c into the x in f of x. So it becomes c plus 5 is equal to whatever k is equal to, which is 6. And then just solve for c. So we're going to subtract 5 here, subtract 5 here, cancel. C is equal to 6 minus 5. That's -1. And therefore, C is equal to -1. Is -1 a value that is between -3 and 4? It is. And so we're going to say yes. That C is equal to -1. And yes, C is a value that is on the interval between A and B, between -3 and 4, okay? All right, so let's try a couple more examples. All right, so we've got another great example here. It says that f of x is the function x squared plus 2x minus 22 on the interval from A to B. And it says that if f of c is equal to k, all right, so if c is some value, in fact, another way that we could write this, we can see down here that k is -7, right? So what we might do is we might actually put -7 right here in the problem, and we can see that a and b are 0 and 5. And so what we might do is, in the problem, is instead of writing a and b, we might say from 0 to 5. And in that case, we wouldn't even need to have the supplemental information. So now what we're saying is, if f of c is equal to -7, then is c a value on the interval from 0 to 5? Okay? And so, I'm going to erase this. So basically, like I said, all we have to do here is plug c in for x in the function. So we're going to rewrite this, but instead of x squared, we're going to put c squared plus 2c minus 22, and we're going to set that equal to -7. And now all we have to do is solve. Now, here's the thing. Do you see how this is c squared? This is a quadratic. That means that this can have two answers. It can have up to two real answers. If we get two real answers, if one of them falls between 0 and 5 and the other one does not, then we can still say yes. We can still say that c, one of the values of c, that c has a value that is on the interval from 0 to 5. So we only need one of them to be on the interval from 0 to 5 in order to be able to say yes. Okay? So what we're going to do here is, this is a quadratic, and you may remember that to solve a quadratic, we usually want to set one side equal to 0. So we're going to add 7 to make that 0. We're going to add 7 here. That's going to cancel over here and give us 0 over on that side. Bring down the c squared plus 2c. -22 plus 7 is -15. Now, this is factorable. This is a product sum factoring situation. There are two numbers that when you add them together, you get +2, and when you multiply them together, you get -15. Those numbers are +5 and -3. So we're going to set this up as c plus 5 times c minus 3 is equal to 0. And you may recall that in order to solve this kind of a quadratic, we have to set each one of these equal to 0 and solve. So we're going to do c plus 5 is equal to 0, and c minus 3 is equal to 0. Here we're going to subtract 5 from both sides, and we get c is equal to -5. Is -5 between 0 and 5? It's not. Between 0 and 5 is all positive numbers and 0. But this is a negative number, so this is not between 0 and 5. But over here, to solve for c minus 3, we're going to add 3 to both sides, and we're going to get c is equal to 3. And 3 is between 0 and 5, and therefore we can say yes. Is c a value on the interval from 0 to 5? Yes, it is, and that value is 3. And so what I'm going to want you to do in the quiz is I'm going to want you to identify the value of c. If there is a value of c between these two numbers, I'm going to want you to identify that value and then say either yes or no. Okay? Let's do maybe one or two more examples. All right, here's another example, one with a trigonometric function. Just got to keep you on your toes. We got to remember that we're always dealing with different kinds of functions. So it says, let's say that f of x is equal to cosine of x on the interval from a to b. Okay? And here a to b is from pi over 4 up to pi over 2. So now it's saying is, if f of c is equal to square root of 3 over 2, meaning the output of the function, when you plug c into cosine of x, when you plug c in, you get the output square root of 3 over 2. So if f of c is equal to square root of 3 over 2, then is c a value on the interval from pi over 4 to pi over 2? Now some of you who are strong in trig may already know the answer to this, but you still got to work it out. If you want to, pause the video, solve for c, and then answer whether it's on the interval from pi over 4 to pi over 2. All right, so what we're going to do is we're going to plug the letter c into this function cosine of x. So we're going to write cosine of c is equal to square root of 3 over 2. Now remember, with trigonometric functions, if there is a solution, then there's probably an infinite number of solutions because of the cycling of trigonometric functions, okay? So we can solve here, and you can go back to your pre-calculus and remember that, well, our initial solution, we do have a solution that's in the first quadrant of the unit circle where c is equal to pi over 6, right? That's one solution. Then if we go around to the second quadrant does not have a solution for cosine at square root of 3 over 2. But if we go to the third quadrant, also, we're not going to have a positive square root of 3 over 2. Remember, cosine is only positive in the first quadrant and in the fourth quadrant, right? So we got to go all the way around to the fourth quadrant to get a positive square root of 3 over 2 again. So now c is going to be equal to, that's at 11 pi over 6. And then there's another solution for c at 13 pi over 6. And then another solution for c at 23 pi over, did I get that right? 6 double, 12, 13, yep, over 6, okay? And we can go on to infinity. The question is, are any of these values between pi over 4 and pi over 2? No, pi over 6 is less than pi over 4, and 11 pi over 6 is greater than pi over 2. And therefore, none of these solutions are on the interval from pi over 4 to pi over 2. So when we say, if f of c results in square root of 3 over 2, then is this c value, is it a value that's in between pi over 4 and pi over 2? And the answer here is no. It cannot give you any outputs that are between pi over 4 and pi over 2. Okay, let's do maybe one more example, and this one we may need a graphing calculator or Desmos in order to solve it. All right, so here's our last one. If you want to, you can pause this and you can try and figure it out for yourself, but you're probably going to need either Desmos or a graphing calculator to be able to come up with a numerical answer. Otherwise, I'm going to show you how to come up with a non-decimal answer, something very algebraically precise, okay? All right, so it says let f of x equal natural log of x on the interval from a to b. In this case, a to b is 1 to 9, okay? So it says that if f of c is equal to 2, meaning were you to plug the value c into f of x, the answer would be 2, okay? Then is c a value on the interval from 1 to 9, okay? And so in order to solve this, we're going to plug c in for x in the function f of x. So we're going to have the natural log of c is equal to, and then we're going to set it equal to whatever output it's talking about. This is the k value, right, is equal to 2. Now you may say, well, how do I solve this? Well, there's a couple ways to do this. Like I said, in Desmos, you can first of all, we're going to want to set this equal to 0. If we're going to do it in Desmos, we're going to set it equal to 0. Also, if you're going to do it in a graphing calculator, you're probably going to have to set it equal to 0. Now, there are ways of doing it without setting it equal to 0, but they're a little more complicated, and I can make a video on that another time. But for now, what we're going to do is we're going to subtract 2 from both sides. We're now going to have the natural log of c minus 2 is equal to 0. Now, when we put this in Desmos or in a graphing calculator, instead of putting c here, we're going to have to put in x, okay? All right, so let's jump over to Desmos, and we'll solve this. Okay, so here we are in Desmos, and we don't have to modify the graph at all. We're not going to do anything really visual except for find a single point. So all I have to do here is this, is type in y is equal to the natural log of, natural log of x minus 2, right? And now we know that we're setting this equal to 0. So all I have to do is go along the x-axis where y is equal to 0. And see this dot over here? Just point at that dot, and that gives me my answer. My answer is 7.389, okay? If you want to see how I did that one more time, all I did was I just typed in my function. I don't even have to type in y equals. I can just type in natural log of x
minus 2. And then if I want to know where it's equal to 0, I just go along the x-axis until I get to a dot, and bam, 7.389. And that is my solution for x, or in this case for c.
I can also do this in a graphing calculator. If I go up here to y equals, okay, you can see that it opens up this menu where I can type in functions, and I'm going to key in natural log of x minus 2. So there's an ln button. I'm going to put in an x, close the parenthesis, minus 2. So I'm just keying in natural log of x minus 2. Then I'm going to press this graph button all the way over here, and it's going to go ahead and graph that function for me. And now what I'm going to do is, do you see how the 0 is all the way over here where it crosses the x-axis? That's where this is going to be equal to 0. Equal to 0 means crossing the x-axis, right? And the way that I'm going to find that 0 is I'm going to press the second button, then I'm going to press the trace button, which gives me the calculate menu. Do you see the second option here that says 0? So I'm going to arrow down to that, and I'm going to press enter. And then it says left bound. And what I'm going to do is I'm going to put in a number that's over here to the left of that 0. So any number over here will do. I'm going to key in 1. Okay. Enter. And then you can see it crosses over somewhere over here around maybe 7, 8, or 9. It says right bound. I need the upper bound. And so I'm going to key in maybe 10. So 10, enter. And then it says guess. When it gets to guess, if there's only one answer, I'm just going to press enter. But if there's more than one possible answer, I'm going to key in the number that it's closer to. And so for now, I'm just going to press enter. And you can see that it's going to give me the answer. Same answer, 7.389? 7.389. And that's what we're going to put in as our answer here for C. Okay? So, in this case, I can't find my red marker. C is equal to 7.389, right? And you can see 7.389, is this a value that's between 1 and 9? It sure is. So we're going to say yes. Now, there is one other way to solve this. The problem is that you still are going to need some kind of calculator to be able to verify that the value is between 1 and 9. So to solve, we're going to go backwards here. We're going to go to where it's equal to 2 here. And if you recall your Algebra 2 or your college algebra, you may have learned this in pre-calculus even, is that you can actually cancel. You can solve for C algebraically by doing e to the power of here. And if you do e to the power of on the left, you have to do e to the power of on the right. E to the power of will cancel natural log and bring down the c. And then you have e to the second power. So c is equal to e to the second power. Now, if you are a person who already knows that e to the second power, because e is less than 3 but larger than 1, you know that when you square e squared, it's going to give you an answer that's between 1 and 9. But that may be a little too complicated for some of you. But for those of you that it is not complicated, you'll know that e squared is between 1 and 9, and you can answer yes. If you get e squared, you can also just grab a scientific calculator and type in e squared, and you can see that it gives you 7.389. Okay? And so there are several ways that you can solve a problem like this, but all of them end in the same exact place, that c is equal to 7.389 approximately, or e squared, and that value is a value on the interval from 1 to 9. Okay, so that's it for our second segment here. We're working up to the intermediate value theorem. So you've now learned about identifying an output value that's between two output values, and an input value that is on an interval between two input values. If we put that together with what you learned in the previous set of lessons on continuity and discontinuities, we can put all of that information together to understand the intermediate value theorem.